too much. So the next part is what we have. 1S, right? So did you read that part? Mel, you didn't read the 1S part. Okay, so I'll read it. So it basically a circuit consists of 3 resistors in a series circuit, right? To a 24.6 volt battery. The current in the circuit is 0.0327 amps, given that R1 is equal to 255.2 ohms and R2 is equal to 157.8 ohms. Find A, the resistance of R3, and B, the potential difference across each resistor. Now that's called voltage drop. All right, let's go back up to the top, to the very beginning, and I'm going to put in the chat the notes that Miss Brown elegantly set up for us. First thing she gave us is an understanding of the notes you need to tackle this problem, and she also gave us what it means, what each value means in terms of our knowns and unknowns. So I'm going to put this back here. You guys can establish that. Okay. So here we go so far, right? We have REQ is equal to R1.
I can't see your screen. It's frozen on Esbis.
It's froze on SB. Oh no, I'm
Yeah,
putting it in the chat. Okay, but no, that's
what I
cool.
see.
Okay, let me move this over and do it here too. I was about to, Gabe, but see, Gabe know what I'm supposed to be doing. Thank you, Gabriel. All right, so they log into Minds. This is what he's talking about. But I put in the chat what I think we need initially. Yeah, Lisa.
Can I put the other notes in there? Not the problem, but the thing you told us before we started the problem.
Yes, do it very quickly because you know I got to turn it off again. Go ahead. That's it? Okay. So she gave us, oh, Alexis gave us something too. Dang, I should have left it on for a second. Okay. Did he type up everything? Dang. Okay. Way to go. So Alexis helped us out, everybody, with what you need to have the exit slip done. So let's do that because he's helping us get this done. I'm not trying to fly through this, everybody, but technically this is was it Thursday? You're supposed to have your synchronous day. So I want to make sure you got everything you need to do because on synchronous days, asynchronous days, you come in as like a class, it's like an office hour, and you're able to go back and be like, Tyler, what about this problem? And I can help you through it. What about this problem? Those are what those days are for, so you guys can get caught up. Synchronous days, that's where we're going to be doing instruction, and you should be seeing the actual problem that you need to be practicing on done. It might be a new one, it might be a review, it just depends. So pay attention to those schedules. The thing you need is the document. That's what Gabriel's referring to. So I'm going to go to Google Docs. And I'm going to show you how it's supposed to be set up in terms of you solving this, right? Okay, so there we go. First things first, you're going to name it Do Now, right? And today is the what? The 28th. My October is gone of 2020. Okay, so far so good. You need your header. In case you forgot how to do all this, you have to do this. You also need, let me zoom in because somebody's gonna be like, I can't see that. Well, I mean, you only need to see a little bit to follow directions. You have to type it with me. So it'd be 28th of October 2020. Period is, this is the third period, right? And you guys are Intro to Engineering with robotics students. And there's some projects coming up second quarter for projects like students to do at home. But the problem is students are not doing the basic work. So it's hard to get to the fun stuff. All right, so what do you need? You need the title. And the title I think was given in the chat. Let me see. Yeah, no one gave a title yet. But if you don't know what the title is, you just go to ESB. All right. And it's right here as the assignment link. So it's Do Now, 3 resistors in series. Okay. The term is in there, and we talked about that when we was doing that slide deck. So I think that's what threw me off from my recording. So it's 3 resistors, right? in series, right? And that's a series circuit. You're gonna center this. Next is what I think Alexis gave us, and that is over here our exit slip portion. Okay. I see Sinclair is in the camera, so she's back. I was calling your name, Sinclair. Welcome back. She made it back. All right, so we'll copy this over to our document.
Sorry,
Yeah, I was calling your name earlier. You didn't respond, but you're back.
Oh,
It's
my
all
bad.
good. Okay, so I kind of Alexis kind of did the exit slip for you. You're gonna use his definitions, right? So don't forget that part. Next is the question, and I just read the question to you guys. So let me come right here in the chat. I'm grabbing literally all this from the chat. If you've been in class so far, you can grab what I'm grabbing, so you can get caught up. I'm just copy and pasting it over. All right, so now we're set up to begin the problem. This is where Lisa's notes come into play. And this is the very last thing I think, no, right before Alexis and Lisa posting the notes. So the first set of notes you need in the center of the page is this definition, right? And that's our equivalent resistance. Isn't that our classroom term today? All right, so we're gonna center that because that's our first set of notes. Okay. So equivalent resistance for resistors in series is equal to equivalent resistance. This is supposed to say REQ, so you can know what it means. But equivalent resistance is basically made up for, and this is the definition right here, guys, okay? So don't get that confused. This part right here, just underline it so you know that's the definition of what you're doing. Now this means in word form what it is. Equivalent resistance is equivalent to resistor 1 or resistance 1, you can say that, resistance 2 or resistance 3. Now these are all resistors, but resistance is what happens to the current. These dots just means you can have a resistor 4, resistor 5, so on and so forth. All right, so what do we do from here? Well, we got to designate the rest like Lisa did. So how is it written? Well, this is the part Lisa was trying to say. Let's put that into the chat because that goes before that, right? You're also going to need another equation known as Ohm's law. We talked about Ohm's law in great detail yesterday. Okay, so place that there. And it's in the chat. You just got to find it and piece your document together. All right, so let's space this out a little bit. No, I want it centered because those are your initial notes for that part. So maybe double. There we go. And this is all 10, so I'm gonna make it 14 so you guys can see what I'm about to do to this. So this is how it is, right? But it's not R1 like that. It's R subscript 1. So let's go through and edit our document correctly. All right, so it's R1. So that's the resistor 1. This will be our resistor 2 subscript, and then resistor 3 subscript. And don't forget, you're gonna dot, which means you can continue the resistor connections with this circuit. All right, so turn that format off, and then it could just be dot. It's usually 3 dots, which means, hey, there's more if there is more, and it'd be.
She put all this in the chat.
And I put all of it in the chat. It's already in the chat though. Yeah, scroll up. It's already in the chat. All right, now omegas, they have to be used. Right? So, and this goes dot, like I was saying, because you have more resistors. But the same, we're going to be using after this step, and I don't think it's in the notes, but after this step, you have to use a symbol for ohms, which means omega. So it's the same thing with this here, where this would be omega. And what do I mean by omega? You're going to go to special characters. So this is basically total ohms, like all the ohms in the system, that's equivalent resistance. And this will be total omega in one moment. So let me show you what that looks like. You gotta go to special characters. And for every ohm, you're gonna replace it with omega. So I'll highlight that, insert, Go to special characters. And you're going to click on arrows section to change the category to math. Once you do that, you type in here looking for OMEGA for omega. And this is the symbol omega. Okay, looks like that. And all you do is you change each of those to each of these ohms to omega. That's what it is when you're going to use it in your known and unknown values. Now we can continue. So Ohm's law, we discussed it. All right. And just so you get it right, this is also ohms, right? So now we're ready for our known and unknown values. All right, I'm going to go back to what Lisa put in the chat already. And I'm referring everybody to what I just put in the chat already, again, which was Lisa's notes at 12:32 p.m. It's already in the chat. So let's grab the known and unknown values and let's edit that. And then we got to see, I think Lisa said she already checked it. We got to see if the numbers match up. And again, please don't cut corners, because I do give out, I do take off a lot of credit for work turned in sloppy. Meaning it's not even the way we edited it. You just copied and pasted and like, here you go, Tyler. That's like throwing some work on my desk any type of way. And I'm just going to treat it the same way you did it without too much concern. Take your time and do the work right. Okay, so this is this. That 3 has a change because that's subscript. That ohms has a change, right? That's why I'm reviewing, because I was telling people to get this, and maybe either I don't remember not telling you, or you probably just didn't hear it. I don't know. So wait a minute. Does she have all parts of that? I gotta go back upstairs and find it. All right, so let's edit this out, right? These are your notes section, so I know it's gonna get bigger. I'm just bring it down one page because I don't want it to overlap. So we'll make this 14. That's what it's bigger. You can see it, and just bring all this down so you can see your known and unknowns on one page. Cool. Just cleaning it up a little bit because we got values that are disappearing on me. So I didn't want you to delete that. Come here. There we go. Back one. That's a lot better. Okay, cool. And then don't forget about this one. Okay. Now it's very visible. Let's go up and see what we have, if it matches the problem. So the first resistor is 255.2 ohms. Let's see what Lisa put. And yep, she got the first resistor right. Resistor 2, she said it should be 157.8 ohms. She got that right. And then did it give us the current? Why, yes, they did. The current in the circuit is 0.0327. She put that in there. And you have to put your dimensions. I'm seeing students not putting dimensions after numbers. Please don't do that. That defeats the purpose of the problem. All right, so these are omegas, right? We just talked about those. Oops, I did that wrong. Come here. So we're going to take an omega that you should have inserted in your previous notes. And I'm going to replace these here, right? So that is omega. That is omega. And don't forget, that's omega. And of course, omega. We got some more edits. This is REQ, is subscripted. Format text. And that's REQ there. This is R3 subscript. We come here, this is R1 subscript. We did all these edits earlier. So you got to do it everywhere. You got to stay consistent, basically. It's R2 subscript. Subscript. All right. I know you're going to be like, oh, that's so petty. Y'all go take that HVAC program or a licensed nurse, and you don't do these certain things, you might not make the cut or make the money, because they're going to be like, that person is not focused. It's RQ. I was like, did I do it upstairs? This is all supposed to be subscripted. I just didn't see that. There we go. That's the thing of beauty. Okay, so we have what we need. All right. Now what we're gonna do is, where's the rest of the notes that she gave us? Yeah, she did everything. Let's see. We gotta clean up the rest of our notes. Once she did that, there was a strategy. So we're gonna grab all that for the strategy. It's 12:46. So moving kind of fast. We didn't even get to the circuit part, you guys. You can still do the circuit. But don't, panic. You got the video recording, and you'll have until 8 p.m. tonight to finish both problems. So the main thing is getting all the notes correct, so you can try it on the second problem or the homework problem. Here's how the second set of notes should be. Okay. So again, go through and edit. We have REQ, that has a change, right? It's going to be subscript. And then each REQ in the system. So here's what she did, and that's why you get a double entry. It's important. She said in the strategy, says sorry for REQ utilizing algebra, right? So to do that, we have to get REQ.
You put that in the chat.
Can I put what in the chat?
That
This part that's already in there, Gabe.
I don't see it.
Go up to 1222. Lisa Brown.
I wasn't in there yet 12:22, so I ain't get it.
Oh, okay. All right. Let me put this part in there. But you guys still got to correct it, though. All right. So strategy. Let's do it because we have some new entries. Some people that came a little late. So here we go. And you should see that. Okay. That helps. And what do we got? So I'm correcting just a little bit of pieces. What I was saying was she used algebra. The goal was to get REQ by itself. She divided by I on both sides. Right. So this step here actually is you cross things out step. You have to include that. Keep telling y'all to do that, and y'all don't. And then y'all looking at me like, well, why my score still low? Because you tried to finesse the work, and it hurts, doesn't it? So we're going to strike this out. Strike that out. Now you end up with a new equation. This step has to be seen in your notes. Okay, let me check this, see who's coming in this room. You guys should be editing everything out, though. Oh, it's Mr. Rush. Okay. So the new equation is not REQ equals this. This is an error right here. It's just REQ, right? Because we crossed out current on both sides, or the other side of it. Lee Carter left the meeting. Joel's just arrived. All right, Joel, you 30 minutes late, dude. I gotta tell you to try again tomorrow. They told us we can't let you guys in 30 minutes late no more. Okay.
I'm 29 minutes, bro.
Oh, I'm sorry, bro. You gotta come on time. They told us that's the policy.
You said 30 minutes. It's 29.
Hey, dude, I won't have to stop and go back. Like,
Hey, bro.
Tyler.
Yeah, who's that? Carter?
Yeah, I had just lagged out.
Okay, my screen went out. Let me see what's going on.
My connection has just dropped out. Can you the thing that
gotta-
you just posted? Can you repost it in there? Because I was going to copy and paste, but I had lagged out.
I got you. But you guys got to keep up. So try to type up without on the screen because we haven't got to the simulation. We reposting stuff. I'm starting to think people are not paying attention. You gotta keep up because you should already have copied these notes over to the document. Just because y'all slow the class down don't mean the work is not due. Okay. Where are we at? I posted the last time, but I want to get through the corrections. All right, so I just removed the I from over here, and you want to make sure the REQ part right here is just subscripted. We're going to continue on with, that's messing me up. There we go. So we're going to continue on editing what needs to be edited. So this REQ right here changes, right? Somebody 29 minutes, brother. Go on somewhere. So we're going to change all these REQs, and then we're going to cross out something else. So I'm going to take this edited REQ I got here, copy it, and I'm just going to edit it out so it matches. You got to stay consistent. Okay. So that looks better. And then what crosses out here? Well, we got volts over amps. That makes ohms. So these are gone when you do that in this step. And then volts as well. Okay. Cool. So now this is how you got to the ohms part. That looks extremely clean. All right, now we got to fix all this other stuff. This is REQ subscript. This is R1 subscript. All that has to change, everybody, okay? And then you continue on with the notes. And the next part is the voltage values, because we found out R3 here. So what I was saying in this step is ohms crosses out.
Hey, Mr. Tyler.
Who's that?
Wallace. Hey, can you go up a little to the crossout part?
To this part?
Right there.
Okay.
Right, what a vote. Yeah, right here.
Okay. Okay, so hold there for a second while I correct the documents more.
Ain't you posting this video on ASB?
Yes, I am.
Alright, can you tell me when you posting it?
It's usually by 4 p.m. there, or 4:30.
Alright, cause I hardly got nothing.
Already got the notes?
Yeah, I got the notes, but it's not on my Google Docs. I just took pictures of it.
Okay. You gotta type it up. Okay, who is texting me? What do you want? Oh my goodness. They're killing me. Y'all gonna go on somewhere. Alright, I'm trying to teach and they trying to text me and ask me questions. It's not gonna happen, staff. Call reality. Y'all gotta get better. Alright, so I'm just making the edits. Okay, so you just want to go through and make sure these are the corrections to the document. See, I'm subscripting the right things. You have to do the same. All right. That's how your document should look. I'm going to blow it up to 14 so you guys can see, but I'm just making it correct. The quickest way to do this is to use subscripts, right? So as I did all that, this is supposed to be subscripted too. So much better. Awesome. These are all R3s. Okay. And the last part is, of course, all the ohms have to change to the symbols. So let me grab the symbols. One moment, you guys. Okay, sorry about that. Just got a phone call about my child. Anyway, so you're gonna strike these out. I hope you guys see the edits I made to make the document correct. All right, so I'm gonna cross each of these out because these all cross out to make 1 ohm value. They combine basically. All right, so only one you have is that one value of ohms out here. That's what the ohms. Okay. Now, I think that's everything. It's 12:56. Did we get the voltage drops? No, we didn't. All right, let me go through the voltage drops. Let me go back up to the top. That's the last part. This is a very long problem, by the way, so I'll be taking all the notes down. Later on, Lisa gave us the rest of the calculations. So it's the part B part. That was just part A. So part B, you have to find the voltage or potential differences for all of them. So notes state are like this. I'm gonna put this in the chat again because somebody's gonna be like, I didn't see it. There it is. And there's one more, it's called V3. This is a review problem, so nobody should be panicking, especially if you were in class. So take the notes down because you're going to need it. We have a quiz on Friday, and this will surface again like a serpent and bite you in the butt. Not unless you have notes like I'm giving you again today. You will also need to do the simulation for each problem in the quiz. So some problems are going to require a graph. Some problems are going to require simulation, just a snapshot. But they're going to need to have the steps and those parts in there. Next week, we have final exams. In final exams, we're going to have to talk about your best works and make a Bitmoji classroom, or you'll be taking the exam. It's pretty much up to you.
Mom, you will show me how to do the what I was doing yesterday when I had joined.
You have to use your synchronous days for that. That's Thursday. So you got to come to office hours. We talking about what yesterday, the problem or something about the problem or something about the application?
No, I'm talking about that little simulation I was doing.
Right, we're about to talk about that right now because you guys got to put your snapshot in there, and we're almost out of time. So, what I was saying is, if you have my Bitmoji classroom, and I got to finish editing this here. Let me finish editing this so you guys will have the correct notes. So, part B, we just got finished with part A, by the way. You need to have all these steps. Now, this is again a thing of making it look correct. That's R1 there. This is V1 there. You did something else. There we go. This is V1. Okay. I was going through and changing what should. All the ohms should change to the symbol. Gosh darn it. Right, so I'm just changing them all to V1s. And then, of course, you have amps and ohms that cross out here to make volts. When you multiply them together like that. So it's going to be cross out amps. But this symbol right here should be ohms. Not saying it, but the symbol. All right, so that's ohms. This is ohms. And format, cross it out. Right? And now we have, it looks proper. So I need you guys to do this to all these steps. Except this is V2, right? And that's R2. And then you do the same thing. You fix this part. So do all your V2s, all your V3s, because these are called your potential differences or voltage drops, as they're called in a technician field or engineering field. So you have to have yours edited just like this. But I want to get started on the simulation because we still have to do our snapshot, right? So to find it, the simulation itself, you would want to come to the classroom that I gave you. It's also in Edsby. If you come here, like I don't see it in the chat, okay? No problem. That's why I told you guys to look at Edsby. Because we go here, if you look at yesterday's recording of what we did, the video is these pictures, but it's also in library. But my classroom link, it says the link for my Bitmoji classroom is, you click on that, and it's pretty much this link. So I'll put it in the chat, open it up, and that way you'll always know where the link for, that's why I did it, so it's like a one-stop shop for you guys. When you click on it, make sure you're using Google Chrome. And what's going to happen is you want to make sure you go to, you see me when you start the presentation off. You click on me sitting on this chair, by the fireplace. And then next, you click on this icon here, which is the physics classroom. The physics classroom has all my applications. So you click on that, and it'll take you here. Now, don't pay attention to the objectives. That's for physics students. This is the word of the day for physics students, but this is the word of this is a classroom term for physics, but this is the word of the day for school. So the simulation to click on is this right here. All right, has this little bulb connected to a little circuit. You can click on that, and it's going to load a simulator. I hope everybody saw what I just did. Okay. All right, so is everybody there yet?
What did you press again? I know you said it was in a classroom thing, but what?
Okay, so let me go back. So we're in the physics classroom, right, Lisa? And when we're in there, what you want to click on, this is not the physics classroom. So you click on me to start off when you start the link. You click on the physics classroom. There is this circuit right here. It's like a little battery connected to wires and a bulb.
Thank you.
Okay. So when you did that, this simulator, is this the right one? That's physics. That's not
So
it.
what you just posted in the chat, what that was?
That's the link to the classroom.
All right, when I click on that, what I click on after that?
I just explained that. What was you doing? This is gonna be the third time I explained it. Pay attention, all right? You click on me. Hope you're following because you were doing something else. I explained it twice. Then you click on physics here. Okay. Did you do that?
Yeah.
And did you see the physics classroom?
Yeah.
And then you go to this little circuit here. Did you click on it?
Yeah.
All right. It should start this here. Is everybody here? Because we're running out of time. It's 1:03. We got 17 minutes left. And I want you guys to get this picture in there so you can get full credit on this assignment. So we're going to go to lab today. Okay. This has a lot more stuff that you can experiment with. But here's all you need, everyone. So you're going to set up your circuit just like I'm doing. Grab a battery. This is your potential difference or your epsilon, that little funny symbol in your nose. This is your battery. Okay. If you click on the battery, you could change. If you just click on the battery, it has a yellow outline. You can change the voltage. I don't remember what the voltage was in our problem. Let's take a look. That's what we're setting it up for. So we have one battery, and that was 24.6 volts. So guess what you got to set your battery to? Come over here to 24 point. Just try to get close enough. Don't put 24, right? Move it back up. So as you can see, it's at 24. I took that from the problem. We're gonna grab some wires and we're gonna make a series circuit. We've done this before. So first wire, I'm just gonna put two ends of the battery connected to a wire. And it has to be a series circuit. So I want to see a box. No crazy diagrams. It has to work. If you don't do it the way I'm doing it and you have a glitch, I want to tell you to start over and do what I asked you to do. Okay, so I'm taking a wire and I'm making two junction points. And you can stretch the wires out once they're connected. The red circles are junction points for these wires. Okay, so let's keep going. We can grab a resistor. This is our R1, or resistance 1. Grab a wire, connect, stretch it out a little bit because we're going to come down. And we're going to have 3 resistors connected in an equidistant fashion. The little blue circles you see in between the resistor and the wires as well as the battery are electrons. And they are not moving. When they are not moving, I should say, it means you did something wrong because there's no current flow, I. And then I'll take another wire, and I hope everybody's watching what I'm doing. The video will be available. You need to be able to do this on Friday as well because it's going to be on the quiz. When the problem says also show all diagrams, you need to know how to do that. So you see I effectively done this. I need you to, because the next step is I'm going to put a light bulb in here, and you'll see why it's important to have a resistor in there. So I'm just going to take a wire, and this is called next week, if we can get to it, as a new topic, a parallel circuit. And you learn about that when you guys are technicians and engineers installing things in houses. So the parallel circuit, you grab a load like a bulb, to rotate it like that, and all I'm going to do is I'm going to connect one part of the bulb here and one part of the bulb there. Same thing that happens. And then you have, as we say, as we Masons say, let there be light. There it is. So there's two factors, right? One is this is the real industry version of your diagram. For today, you did the cartoon last week. For today, you need to do, because I'm extremely excited at this HVAC program. These are the things, this is called a blueprint version of what you would see in your house if you were troubleshooting electricity. So I need a snapshot of this, but that's not it. We have to connect some tools to this. So I want to see how much resistance is on resistor 1. You take your black lead and you put it on the negative side of the resistor. And you take your red lead and you put it on the positive side. That's a voltage drop. That's what we had in our calculations, those V1s, V2s, V3s. All right. You can do something like this in a household. You can really get a powerful job. So I'm going to cut this and I'm going to include in this circuit, and cut this here too. Include in this circuit an ammeter. This shows how much current one has. So I'm going to come from here to here, and we'll see when you connect this in line with it, how much current you have going to the actual light bulb. I've used these in my family's household, or my family's business, because we're carpenters. I've been that way since I was 8 years old. We've used these type of tools to see where power was in the house. Okay. For an ammeter, you have to connect it in line with the circuit. That's the most important thing. For a voltmeter, you could test each potential difference at each resistor or load. All right, so this is in essence all you need. I was going to show you how to do the resistor changes, but I don't think that's necessary because you won't see the color codes of resistors. And I don't want to spend too much time on that. But what I do want is a snapshot included into your document. So after you do what I just did with these settings, your voltmeter should say 10.11 volts. Your current meter should say 0.38 amps. And that's because you set up the way I said it. Take a screenshot. I got a screenshot from this corner here. I'll go to Google, where my document is, come down, and we're missing some notes from our unknowns, the voltage values. We got to put those in there. So I'm gonna come over and say, one moment, because I want to fix that. I didn't know we didn't put that. So V1 is going to be equal to what is what that question is asking you, volts. And we calculated that later on from Lisa's notes. V2 is going to be number in volts. And then I'm just going to take this. No, I'm going to take only this, not all that. And this is the last part of your unknown values. V3, 3. And just be sure to make sure there's a subscript. So this one is this one is this, and this one is this. Okay. So far, so good. I'm gonna come down and just expand this a little bit so you can see it. And then I'll plug in the image I just screenshotted into my document. That to subscript all these V2s and whatnot. So that's the solution. But the picture, I want the picture exactly after the question, so you get a visual of what you're working on. So come right before these notes, and then hit insert. Right? Insert image, and then we're going to upload from computer. And there it is, the picture. Okay, so put that there. And as the French say, et voila, it'll pop up into your document. It says creating images. So there it goes. Bam. And it's inserted into your document, so you're good. All right, now is the time for share outs. I'm going to turn on the sharing screen privilege. Each of you can share your screen if you choose to, but we have to do it quickly because we're running out of time. You just have to show me that you have. You said what, Elisa? So you can't.
Mr. Tyler. I was gonna ask,
Yeah.
no, I was gonna ask, what's that thing on the little tip of the little house? I don't know, the little. I couldn't find
You
it,
talking about Omega?
so I still gotta input my screenshot.
Oh, you
No, on the little
how do
image.
you do that? Like this?
Yeah, yeah, cause I wanted to see the full picture without the.
So you wanted to see it with a cartoon? With a cartoon?
Oh, that was a light bulb. Thank you.
Right. So if you look at a spreadsheet, I'm not a spreadsheet, a blueprint. There's a blueprint version, and then there's a cartoon version. So, all right. I don't know if that helped out or not. Okay, so who would like to share first?
Hey, Mr.
Yeah,
Tyler. Hey, Mr. Tyler, can you send me the link to go to this the
to the
circuit?
circuit. You got to build the circuit.
Yeah. Now I'm saying, can you send me the link though to
Yeah,
go
yeah.
to it? So
You didn't find it in the classroom thing?
nah.
Okay, you must have didn't click on that circuit. Let's see here. So that's the actual link. All right, so
I can share out for what I
okay,
did,
I
but
should
I
say
ain't get
now.
to
I
do
guess I
the
got to go down
picture.
the list, but okay. Yeah, I'm
I
gonna
ain't get
turn it
to
on
do the
now.
picture though because my computer just died and I ain't bring my charger while I'm at.
Okay. All right. Well, go ahead and share your screen real quick. Let's see how much you got done. So let me stop presenting. Oh, Dajay got it. Okay, there you go. Okay. There you go. Well, you got it. There you go. Oh, you got a lot done. Okay.
I just did a subscript and stuff when I get to my charger.
Okay. All right. Don't forget there's a V3 part.
Okay.
I will be putting the chat transcripts in SB. So you are great. Make sure you turn everything.
Wait,
Mhm.
Mr. Tyler,
Yeah.
you put the V3 part
In the chat?
in the yeah.
I did already. Yeah.
Can you do it again? Cause my computer died.
Okay. Hold on. I think that's it. Champagne is sharing. Let's see what he has. So you got to fix your subscripts. You didn't subscript nothing. You got to fix that. Yeah, you got the notes, but you got to edit them out, Latrell. It's not correct yet, but you close.
All right.
So don't forget your picture too, your simulation. See
Oh
you.
yeah.
Yeah, so don't forget to input that in the document like I did. When I was talking about subscripts, just make sure, like I said, you go through and it looks like RE subscript EQ, R subscript 1, and then these symbols. But check the video out and try to get it all together. And don't forget that image.
All right.
Gabriel's now presenting. Go ahead, Gabriel. Can you expand your screen a little bit? You got it side by side. I mean, yeah. There you go. Okay, thank you, Gabe. Yeah. You got the image and everything, dude. And you cropped your image. You're getting better. All right, I just need you to work on subscript and everything, and that homework problem. Okay, homework problem is similar to the problem we just did. You just change the numbers and do the calculation again. All right, so I'll see you tomorrow, sir. Turn it in by 8. Who's next on my list?
I'll go.
I'm going down the list. Go ahead, Lisa. This is for in-class points. It's not just to leave early. Trust me, you need these points. Okay, so I'm looking at Lisa. All right. Lisa, like, you got everything almost. Yeah, so you just got to fix your subscripts. You started on the second problem already, Lisa? Jeez. Okay. All right, knock it out, girl.
Yeah, I just change the numbers.
Okay. Take care of business. I'll see you tomorrow. Who's next in my list? I got Alexa.
Have a good
Go
day.
ahead, Alexis. You too.
We just
Fast.
presented at the same time.
What did you say, Melody? Melody, you jumped in front of Alexis. I was looking at that. Alexis, I saw it all, man. Just finish
Yeah.
everything up, the homework problem too.
Yeah,
Melody,
I got it done.
Huh?
I finished the second problem too.
Okay. Don't forget your image and turn it in by 8.
All right, thank you. Have a wonderful day.
This all I
You
got.
too.
I took pictures of everything else.
You took picture snapshots, Mel?
Yeah.
All right. Make sure you get it all done
All right.
and turned in. Okay. Who's next on my list? I got Wallace. I have Carter. And who's ready to share next? Gotta show you've done something.
Hey, I'm almost done, Mr. Tyler. Hold on, I'm almost done.
Okay. We got 4 more minutes of class to get these points. So, Kyra, what about you? You there?
I share. I couldn't do much because my baby was crying, but I did what I could do.
That's what I'm trying to say. You got till 8 to finish it up. I need to see you started on it at least. Okay. Okay, you got a little started. There you go. You got your header and everything too.
Nah, I was trying to catch up with y'all.
Okay. All right. So watch the video. Try to catch up and get it all done. Okay, Sankara.
Okay.
All right. See you later. I don't know if I got enough for another class. I think it's just one class. I got Sankara. Lee Carter. What about you, sir? What do you have to show? Mr. Carter, are you there? He's not answering. Okay, so 3 more minutes, guys. You can't share today. You can share early class tomorrow. But
Mr. Tyler, you was ready. I'm ready for you. I'm ready.
go ahead. Go ahead and share your screen, man. You know how, right?
Yeah.
All right, knock it out. There you go. Okay, you got the simulation going. What about your document? Oh man, you getting the hang of the class already.
Yeah. I'm trying to. Hey
You
man,
getting the hang of the class.
I'm trying to get out this year, man. I ain't trying to be back.
But you know the stuff you're learning right now is some of the stuff you be learning. Were you at the HVAC thing?
Yeah.
Some of this stuff you'll learn in there too. But okay, just edit your document correctly. I've seen it. You've been keeping up with me. Pretty good. Pretty good.
Yeah.
Keep proving me wrong. All right, turn it in both parts by 8, dude. You enjoy the rest of your day. I think this is the last class I got you for, right?
Yeah.
All right, I'll see you tomorrow. Don't forget to turn it in today, though.
All right.
All right. Lee Carter. Mr. Carter, are you there? Mr. Carter, in 1 minute, the class is going to be over with. I have to follow back up with you tomorrow. All right. So goes the roll call.